On February 7, 2017, engineers at the tallest dam in the United States watched in disbelief as something impossible happened. Water was tearing apart solid concrete. Oroville Dam, a 770-foot earthen giant in Northern California, had just survived one of the wettest winters in a century. But that morning, inspectors spotted an unusual flow pattern on the main spillway. When they got closer, they found a crater, hundreds of feet of reinforced concrete, ripped open like wet cardboard. Water was pouring through the gap and carving into the hillside beneath. Over the next 5 days, the crisis escalated beyond anything California had prepared for. The emergency spillway, which had never been used in nearly 50 years since the dam was built, activated for the first time and immediately began failing. The hillside underneath it was not bedrock, as original engineering reports from the 1960s had assumed. It was weathered rock and loose soil. Water chewed through it in hours. On February 12th, authorities issued the evacuation order. 188,000 people fled their homes. Gas stations ran dry. Highways gridlocked for 5 hours on routes that normally took 20 minutes. For 3 terrifying days, Northern California held its breath, wondering if the dam would hold. It did. Barely. The repair bill came to $1.1 billion. Now, here is the detail from that story that almost nobody talks about. Oroville Dam is an earthen embankment dam, and the material that has been sealing earthen dams against water intrusion since the late 1920s, the same material that is right now protecting nuclear waste repositories designed to last 100,000 years, is a pale grey powder that costs about $2 a pound. It was not part of the original Oroville spillway design, but it was already quietly working inside thousands of other water infrastructure projects across the country, doing exactly what that crumbling concrete could not: stopping water permanently by actually working with it instead of fighting against it. This is sodium bentonite clay, and its story is one of the most fascinating in the history of building materials. Not because someone suppressed it, but because the economics of the modern repair industry made it invisible to the average homeowner, even while the biggest engineering projects on Earth never stopped relying on it. Welcome back to Oracle Prime. If understanding how the world actually works matters to you, subscribe and hit the bell. Let us get into it. Part 1. Born from volcanoes shaped by time. To understand why this powder does what no synthetic sealant can replicate, we need to go back roughly 70 million years. During the late Cretaceous period, massive volcanic eruptions sent enormous clouds of fine ash drifting across what is now the American West. That ash did not just settle on dry land. Much of it fell into shallow, mineral-rich inland seas. Warm, salty water that initiated a slow chemical transformation. Over millions of years, the volcanic glass in that ash broke down and recombined with the surrounding minerals. What emerged was a new type of clay, an aluminum phyllosilicate with a molecular architecture unlike anything else in nature. Scientists eventually named it Bentonite, after Fort Benton, Wyoming, where massive deposits were first formally catalogued in the 1890s. But the real story is not the name, it is the structure. Bentonite belongs to a class of minerals called smectites. Under a powerful enough microscope, its structure looks like a sandwich, incredibly thin layers stacked on top of one another. Each layer is built from sheets of aluminum atoms bonded between sheets of silicon and oxygen, forming what geologists call a TOT lattice. And between those layers sits the key to everything: sodium ions. Here is where the magic happens. Sodium has a powerful electrostatic attraction to water molecules. When dry bentonite contacts water, those sodium ions pull water between the crystal layers with tremendous force. The layers physically push apart. The mineral swells. A single handful of dry sodium bentonite can absorb 7 to 10 times its own weight in water and expand to roughly 15 times its original volume. Multiple independent engineering sources confirm this range consistently, but the truly remarkable property, the one that makes engineers choose it over synthetic alternatives for the most critical waterproofing applications on Earth, is this. The expansion is self-directing. Pack dry bentonite into a crack, and when water begins to penetrate, the mineral does not just sit there passively absorbing. It swells toward the water source first, filling the path of least resistance, then expands laterally, then backfills any remaining voids. The harder the water pushes, the more tightly the swollen clay compresses against the surrounding surfaces. It is reactive waterproofing. The seal gets stronger under pressure, not weaker. Once fully hydrated and confined, bentonite forms a dense gel with a hydraulic conductivity so low that engineers measure it in billionths of a meter per second. To put that in everyday terms, a thin layer of hydrated, confined bentonite, we are talking about a few millimeters, can outperform 2 meters of compacted natural clay in waterproofing performance. Think about that ratio. A layer thinner than a pencil outperforms a wall of clay taller than most people. And here is what separates it from every epoxy, silicone, and polymer sealant on the hardware store shelf. If the seal cracks, the bentonite rehydrates and reseals itself. No maintenance, no reapplication, no return visit from a contractor. Part 2. The quiet workhorse of mega engineering. If sodium bentonite were some obscure folk remedy, you could dismiss it. But the opposite is true. The biggest, most expensive, most safety-critical construction projects on Earth rely on it, right now, today. Start underground. In Urajoki, Finland, a facility called Onkalo is nearing completion. The name means small cave in Finnish, but there is nothing small about its mission. It will be the world's first permanent repository for spent nuclear fuel. The engineering challenge is almost absurd in its ambition. Contain some of the most dangerous material humanity has ever created, 500 meters underground in crystalline bedrock for at least 100,000 years. Not decades, not centuries, 100 millennia. To give you a sense of that timescale, 100,000 years ago, modern humans had not yet left Africa. The engineers designing Onkalo have to guarantee their containment system outlasts every civilization that has ever existed, combined. The containment system, called KBS-3, uses 3 barriers. First, the spent fuel goes into cast iron canisters encased in copper shells. Second, those copper canisters are surrounded by compacted bentonite clay. Third, the bedrock itself. The bentonite is not an afterthought. It is the active barrier. When groundwater eventually reaches those canisters, and over geological time it will, the bentonite will absorb the water, swell, and form an impermeable seal around the copper shell. If any micro-cracks develop in the clay over thousands of years, the material will simply rehydrate and close them. The same facility design is now being built in Forsmark, Sweden, where 12,000 tons of spent nuclear fuel will be stored in 6,000 copper canisters, all shielded by bentonite, inside 60 kilometers of tunnels bored 500 meters into billion-year-old rock. Let that register for a moment. When the nations with the most advanced nuclear programs on Earth needed to choose a material they could trust for 100,000 years of continuous waterproofing, they chose the same grey powder that ranchers in Wyoming have been using to seal stock ponds since the 1920s. Now look at tunneling. During the construction of the Channel Tunnel connecting England and France beneath the English Channel, bentonite slurry was pumped in front of the tunnel boring machines. It served multiple functions: stabilizing the soil face, balancing the immense water and earth pressure at the cutting head, and sealing the excavation walls as the machine advanced. The same technology was used in London's Crossrail project and in the deep foundations of the Burj Khalifa in Dubai. The United States Environmental Protection Agency formally recognizes sodium bentonite as an approved liner material for landfills and hazardous waste containment, precisely because of its impermeability and chemical stability. And in everyday construction, bentonite waterproofing systems have been commercially available in the United States for nearly 80 years. Modern products sandwich bentonite granules between layers of geotextile fabric, creating flexible sheets that contractors roll out against foundation walls and under concrete slabs. These products are manufactured by major companies, sold through normal construction supply channels, and specified by architects and engineers on commercial buildings, parking garages, tunnels, and high-rises across the country. So the question is not whether this material works. That was settled decades ago. The question is, why does the average homeowner have no idea it exists? Part 3. The Economics of Invisibility. And the answer is not a conspiracy. It is something more mundane, but honestly more interesting: market structure. Sodium bentonite is a natural mineral. You cannot patent a mineral. You cannot patent the chemical reaction that makes it swell. You cannot create a proprietary formula, slap a brand name on it, and build a distribution empire around exclusive manufacturing rights. This is the fundamental economic reality that shaped bentonite's disappearance from the consumer market. When a product cannot be patented, no single company has the financial incentive to spend millions on consumer marketing, retail partnerships, or advertising campaigns. There are no bentonite commercials during the Super Bowl. There is no bentonite spokesperson. No one is paying for shelf space at your local hardware chain. Compare that to synthetic sealants, polyurethane foam, silicone cork, EPDM rubber membranes. Every one of those products is proprietary. Everyone has a patent holder, a brand manager, a marketing budget, and a distribution network with profit margins built into every tube and cartridge. When you walk into a hardware store with a leaking pipe, the entire retail environment is designed to steer you toward those products, because those are the products that generate revenue for the store, the distributor, and the manufacturer. Bentonite, by contrast, has no corporate champion. It is sold primarily through agricultural supply stores, drilling supply companies, and specialty construction distributors, channels that the average homeowner never visits. This is also why the professional waterproofing industry, which generates tens of billions of dollars annually, has no incentive to mention it during a sales call. A waterproofing company charging thousands of dollars for a basement treatment is selling labor, proprietary coatings, and warranty service. Recommending a 50-pound bag of bentonite from a farm supply store does not fit that business model. To be clear, this is not villainy. Professional waterproofers provide genuine value. They diagnose complex problems, they handle permits and building codes, they provide warranties, and they address systemic issues that a bag of clay cannot solve. We will get to those limitations shortly. But the economic structure explains why bentonite quietly disappeared from consumer awareness, even as it remained a foundational material in professional engineering. The knowledge never vanished. It simply migrated to places where marketing departments had no reason to follow. Part 4. What you can actually do with it. So let us talk about practical applications, what bentonite genuinely excels at, and exactly how to use it. First, sourcing. You need sodium bentonite, not calcium bentonite. Calcium bentonite has significantly lower swelling capacity and will not provide effective waterproofing. Look for agricultural grade or pond sealing grade sodium bentonite at farm supply stores, drilling supply companies, or online bulk suppliers. A 50-pound bag typically costs between $20 and $40, and that bag will cover a surprisingly large number of applications. Application 1. Sealing a leaking earthen pond. This is the most well-established and widely proven consumer application for bentonite, and it has been the standard solution since the late 1920s. Ranchers, farmers, and homesteaders across the American West have relied on it for nearly a century. If you have a stock pond, irrigation reservoir, or decorative pond that is losing water through soil seepage, bentonite is the go-to material. For a drained pond, spread granular bentonite evenly across the bottom, mix it into the top 3 to 4 inches of soil with a tiller or disc, compact the surface, and refill slowly. For a pond that cannot be drained, sprinkle granular bentonite directly onto the water surface above the suspected leak area. The granules sink, the escaping water draws the clay toward the leak point, and the bentonite hydrates and seals the gap from the inside. Allow 5 to 7 days for full hydration. Application rates vary by soil type. Sandy soils need more bentonite per square foot than clay-rich soils. And here is a practical tip that experienced users know. Keep a few extra bags on hand. If a new seep develops months or years later, you can simply sprinkle more granules over the water and let the process repeat itself. Application 2. Below-grade foundation waterproofing during new construction. If you are building a new structure with a basement or below-grade walls, bentonite waterproofing panels or sheets can be installed against the foundation before backfilling. This is an established construction method used on commercial projects nationwide. The bentonite remains dormant until groundwater contacts it, then swells to create a continuous impermeable barrier. This is a legitimate alternative to synthetic membrane systems and is especially effective in areas with high water tables. Application 3. Sealing well casings and abandoned boreholes. Bentonite chips and granules are the standard material for sealing the annular space around well casings and for plugging abandoned wells to prevent groundwater contamination. Most state well construction codes specifically require or recommend bentonite for this purpose. Application 4. Emergency field repairs for off-grid situations. If you are a homesteader, camper, or outdoors enthusiast, a small bag of bentonite powder is a genuinely useful addition to your kit. Mixed with water into a thick paste, it can seal cracks in earthen water storage, patch leaking containers made of porous materials, or create temporary waterproof barriers. It is non-toxic, environmentally safe, and works with nothing but water and your hands. Part 5. The honest limitations. When bentonite is not the answer. And now for the part that separates useful knowledge from dangerous advice. Because bentonite is not a magic cure-all, and pretending otherwise would be irresponsible. Limitation 1. Bentonite requires confinement to work. This is the most important thing to understand. Bentonite provides waterproofing by swelling and creating pressure against surrounding surfaces. Without confinement, meaning soil, concrete, or another rigid material pressing back against the swollen clay, the bentonite can simply swell outward, lose density, and fail to create an effective seal. It must be confined under a minimum constant pressure to function as a waterproof barrier. This is why you cannot just smear it onto a surface and expect results. Limitation 2. It does not work on pressurized plumbing. Let me be direct about this. Sodium bentonite is not designed to repair leaking pipes inside your home. Pressurized water supply lines, drain connections, and pipe fittings require mechanical repairs, replacement fittings, soldering, compression connections, or professional pipework. Bentonite cannot withstand the flow velocity and pressure inside a plumbing system, and attempting to use it there could result in a catastrophic failure that causes far more damage than the original leak. If you have a leaking pipe, call a plumber. Limitation 3. Wet-dry cycling can compromise the seal. Bentonite works best in environments where it stays consistently hydrated. In applications where the material repeatedly dries out and re-wets, such as above-grade exterior surfaces or areas with seasonal water table fluctuations, the clay can shrink, crack, and lose its seal over time. It will rehydrate and re-swell when water returns, but repeated extreme cycles can degrade performance. This is why it excels in below-grade applications where consistent soil moisture maintains hydration. Limitation 4. Existing basement leaks require professional diagnosis. If your basement is already leaking, the cause could be hydrostatic pressure, foundation cracks, failed drainage systems, grading issues, or plumbing failures. Simply packing bentonite into a visible crack from the inside without understanding the underlying cause and ensuring proper confinement on the exterior is unlikely to produce a lasting repair. Professional waterproofing companies have diagnostic tools and installation methods that address these systemic issues. Their services are genuinely valuable, and for most existing residential basement problems, they are the right call. Limitation 5. Building codes and insurance. Many jurisdictions have specific building codes governing foundation waterproofing methods and materials. Some insurance policies require that repairs meet certain standards. Before undertaking any significant waterproofing project, check your local code requirements and insurance policy terms. The honest summary: bentonite is extraordinarily effective in the right applications. Pond sealing, new construction below-grade waterproofing, well sealing, and off-grid emergency use. It is not a substitute for professional plumbing repair, and it is not a retroactive fix for complex existing basement water problems without professional guidance. Part 6. Why this matters more than a leaking pipe. Step back from the technical details for a moment, because there is a larger principle at work in this story that applies far beyond waterproofing. We live in a consumer economy that overwhelmingly rewards complexity. The more steps a solution requires, the more products it involves, the more specialized the labor, the more money it generates at every point in the supply chain. Simple, natural, unpatentable solutions, no matter how effective, tend to fade from public awareness because no one profits enough from them to keep them visible. This is not unique to bentonite. It happens across dozens of categories. It is the reason your grandmother's cleaning remedies were replaced by 17 specialty sprays. It is the reason simple, durable tools were replaced by battery-powered gadgets with planned obsolescence cycles. The pattern is always the same. A natural or simple solution works. It cannot be patented. A synthetic alternative appears that can be branded and sold at premium margins. The branded product gets the marketing budget, the shelf space, the professional endorsements. Within a generation, the original solution fades from common knowledge, not because it stopped working, but because no one had a financial reason to keep talking about it. Bentonite is a perfect case study of this pattern because the evidence is so stark. The same material, trusted to protect humanity from nuclear radiation for 100,000 years, is essentially unknown to the person standing in the waterproofing aisle of a hardware store. That disconnect is not a failure of the material, it is a feature of the marketplace. Understanding this pattern is a skill. Once you see it, you start asking better questions every time someone tells you that the only solution to your problem involves an expensive proprietary product and a licensed professional. Sometimes they are right. Sometimes the expensive solution genuinely is the best one. But sometimes, more often than you might expect, there is a 70-million-year-old powder sitting in a farm supply store that does the same job for $2 a pound. Let us go back to Oroville. After the crisis, engineers rebuilt both spillways at a cost of over $1 billion. They anchored new concrete slabs deep into the bedrock. They reinforced the emergency spillway with massive concrete structures and underground cut-off walls. But across the country, in thousands of quieter projects that never make the news, engineers continue to trust sodium bentonite for the jobs where water cannot be allowed to win. In Finnish bedrock, 500 meters underground, it guards nuclear waste that will remain dangerous for longer than human civilization has existed. In tunnels beneath cities, it seals the walls against rivers flowing overhead. In farm ponds across the Great Plains, it stops water from draining into the earth. 70 million years ago, volcanic ash settled into an ancient sea. Through nothing but chemistry and time, it became one of the most effective waterproofing materials ever discovered. It cannot be patented. It cannot be branded. It does not need electricity, maintenance, or a return service call. It simply swells, seals, and endures. The knowledge of what it can do never disappeared. It just stopped being profitable enough for anyone to tell you about it. Now you know. If this changed the way you think about the products on the shelf versus the materials beneath your feet, share this video. Subscribe to Oracle Prime, hit the notification bell, and keep asking the question that matters most. What else is hiding in plain sight, waiting for someone willing to look? Stay curious, stay capable. We will see you in the next one.